Alright guys, so notice that we're given two very stereotypical problems that you're going to be expected to be able to do on your guys' test. And I don't see a test coming in until probably the end of maybe next week, but I'll definitely give you guys a heads up. But first of all, let's just kind of figure out how to solve these two problems so that way we get a good foundation built. So when we do the other problems that we're going to cover today, it seems like it's almost the same thing because it really is. So notice this first one, we're evaluating polynomials. So the first thing they're telling me to do is find p of -1. So what they're really telling you, and what you need to train your mind to understand when you see this, is that you have a polynomial named p. Your input is a -1. It is your job to figure out what the value of that polynomial is when your input is -1. So here is that polynomial p. The way I like to evaluate polynomials is I first rewrite my polynomial, but everywhere I have an x, I write open parentheses. It's just a more visual to me to see where my inputs go. Because I can go back and I'm like, okay, they're telling me to find p of -1. I'm just going to put a -1 everywhere there's parentheses, because everywhere there's a parentheses, there's an x. Everywhere there's an x, that's where my input goes. So notice that they're telling you to find p of -1. This is literally written p -1. It is equal to all the left side, or the right side. Now it's your job to figure out what the right side equals. Now remember the order in which we do math operations. PEMDAS. Is there any work to be done inside of these parentheses? No, so we can move on to exponents. Now we have two exponents, so I'm going to do both of them at the same time, or right after each other to kind of save time. -1 cubed, well that's just telling me to multiply -1 3 times. So that's -1 times -1 times -1. -1 times -1 is a +1, and if I multiply it by that last -1, it equals a -1. So all this equals a -1. Keep in mind that this negative has absolutely nothing to do with that cube. It just stays the same. And I'm going to move on to my other exponent, which is -1 squared. And -1 squared is just -1 times -1, which is a +1. And I'm just going to rewrite everything else the same because I'm going to do everything step by step in terms of my PEMDAS, or the order in which I do math. All right, so far so good. There's no more exponents, which is nice. Now let's do the multiplication. Now remember that whenever you distribute, what you're really doing is multiplying. So this is your time to distribute whatever's in front of the parentheses. A negative times a negative is a +1. This one has no parentheses or anything, so I'm just going to rewrite it because it's really just watching the show. A negative times a negative is a +1. And now you can see that you have 1 plus 1 plus 1, which equals 3. So notice that p of -1 equals a +3. When your input is a -1 into the p function, or the p polynomial, your output is a 3. Okay? Kind of straightforward a little bit. Yeah. All right, is it okay if I erase this just to make more room for number 2? Now, just a reminder that I am recording this and I am going to post it on your Google Classroom. So if you're kind of stuck, if you don't quite remember, you can always look back and you can see for clarification purposes. All right, so this is where the majority of students have a little bit of trouble in terms of this upcoming unit's test. And I think it's because there's a lot of moving things going on. Now, the first thing, the most important, is the first step, understanding what the problem is telling you to do. Notice that this reads 2 times g of c plus 2. So they're literally telling you to say, hey, I want you to take your g function. I want you to input a c plus 2 into the g function, simplify it, multiply it by 2, and then I want you to add it to 3 times whatever that same g function is, but I want to know what that input is with 2c. So notice that I even color coordinated them for you to kind of see, okay, I need to find g of c plus 2, and then I need to multiply it by 2, and then I need to find g of 2c, multiply it by 3, and then add them together. So step 1 of these problems is first understanding the blue and the green. Once you can do that, the rest of it gets mechanical, because it's just that, it's mechanical. Let's start with finding what g of c plus 2 is. Now, remember, your input is c plus 2. Nothing has changed. You still have a g function. So I'm going to rewrite this g function. But everywhere there's an x, I'm going to rewrite open parentheses. So that way I can input whatever input they want me to input, which is a c plus 2. And then again, it's just the kind of repeated thing, but this time with variables. You are looking for g of c plus 2. This is what it equals for. Starting with PEMDAS, is there any work to be done inside these parentheses? No. Is there any exponents? No. Is there any multiplication? Yes, because you're going to distribute that -3. This becomes negative 3c minus 6 minus 4. Now, is there any multiplication, division? Is there any addition or subtraction? Yes, because you can combine by subtracting negative 6 and negative 4, which equals a negative 10. So you now know what g of c plus 2 equals. It equals a negative 3c minus 10. Now, unfortunately for us, that is not the only polynomial that you have to evaluate for this specific problem. You still have to evaluate the same polynomial, but this time you need to input a 2c because you need to find g of 2c. So here's my g function. G of whatever x is going to be equal to a negative 3 times whatever x is minus 4. What are you inputting? A 2c. Now 2c is equal to all this garbage. What part of that garbage am I going to do first? Let me erase this to make it look a little nicer because it's just 2c parentheses. I'm not sure how much nicer it looks, but that was my best attempt. There's no work inside the parentheses, no exponents. Let's do the multiplication. Negative 3 times 2c is a negative 6c. Don't forget to minus 4. Now, analyzing this, is there any way to combine that 6 and that 4? No, right? So that means that you're pretty much done. Now you just have to put it together. Now you have done the hard part. If you can look at the original problem that we had here and understand that you have to find the blue, you have to find the green, and you know how to do it, the rest of it is just straightforward. Because this is 2 times, remember I like to show times with parentheses, whatever g of c plus 2 is. Now what is it? G of c plus 2? Negative 3c minus 10. And then you're going to add it to 3 times whatever g of 2c is, which is the green. And what did the green turn out to equal? Negative 6c minus 4. So again, where would I suggest is understanding where these come from and understanding that you need to find those from the original problem. And that is my best attempt at color coordinating to kind of see where the things kind of come from. Of course, it feels like you should be done, right? We've been on this problem for forever, but you do still have to simplify your life away. Let's start. Is there any work to be done inside the parentheses? No, because we would have done it before. There's no exponents. There is multiplication. Let's start with multiplying. That's a negative 6c minus 20. Distributing this 3, you end up with a negative 18c minus 12. Or a negative 12, whatever which way you want to look at it. And now let's just combine. Negative 6c minus 18c is a negative 24c. Negative 20 minus 12 is a negative 32. And that is it for this problem. It seems like a big problem, but it's really just more time consuming. Because if you know how to evaluate, especially when you're evaluating with variables, the rest of it is just kind of more puzzle-ish, if that makes sense. At least to me, that's what I see when I see these problems. Okay. Is everybody okay with that? All right, cool. So let's go ahead and start doing some more problems. Now, again, remember when I told you that what we're doing today is we're taking one skill that you've learned and another skill that you learned, and we're kind of going to try to solve the exact same problem. So the first thing I want you to do is just to evaluate this function here. I gave you a function. I want you to find f of 2, and I want you to do it just like normal. And then I'm going to show you how to do it using synthetic division, and you'll notice that you get the same answer. But first, let's just practice how to find f of 2 real quickly. All right, guys, so let's evaluate the following function, f of 2 given the following polynomial function. Now, the only way I showed you how to do this so far is by direct substitution. What I mean by direct substitution is literally just substitute that input it into that function, and figure it out. So let's just kind of remind ourselves just to have a second example. The way I like to do is I like to rewrite my function, but everywhere there's parentheses, I like to leave, or everywhere there's an x, I like to leave open parentheses because that's where I know where my input goes. My input in this situation is a positive 2, so that's what I'm going to go ahead and do and plug it in. And now I need to figure out what all that math is. Now let's start with the parentheses. There's no work to be done inside, so let's go ahead and do the exponents. Now this is 2 squared, which is a positive 4. Let me rewrite everything else the same. And now there is no more exponents. Is there any multiplication? And yes, there's two instances that you have to figure out. 4 times 4 is a positive 16. Negative 3 times 2 is a negative 6. And then don't forget your plus 6. Now, all these are just adding, so you can really add up whichever order you want as long as you add them all up. So this negative 6 and positive 6 cancel out. You're left with a positive 6. So, again, when you input a 2, what is your output? 16. Now, let me show you how you can solve this exact same problem using synthetic division, and I'll show you later why it works. Now, does everybody remember synthetic division? Little bit. Now, as soon as I draw this little magical box that I like to call a multiplier, does it come back a little bit? Yeah. Now, whenever you're evaluating polynomials like the one I gave you, and you have an input that's a constant, like 2, it is really easy to find your multiplier because it's literally what you are the value that you're evaluating at. So in this situation, it is a 2. Now, remember when we were straight up dividing polynomials? We would do the opposite, remember? Because it was the root and all that stuff is 0. This time, it's even easier. Just take whatever number you're evaluating. And then you need these magical numbers that come on. Now, does everybody remember the magical numbers? Those magical numbers are the leading coefficients of whatever's being divided. So in this situation, it's still your polynomial. Notice that all I did there was I looked at each one of the terms, and I just took the coefficient, aka the number of each and every single term, which was a 4, a negative 3, and a 6. Now, if you know how to do synthetic division, this is literally the hardest part, is just figuring out where everything comes from. Now, does everybody know where the green comes from? Cool. Everybody know where the purple comes from? Now we have to do the actual math. Now, remember, the first thing you want to do is bring down your first coefficient, kind of as a starting point. Remember, I call this the multiplier because anything underneath, you multiply your multiplier. 2 times 4 is 8. Does anybody remember what you do above the line? You add. Negative 3 plus 5 nowadays, or negative 3 plus 8 is 5. And then you just repeat the process. You times below the line. 2 times 5 is 10. Now 6 plus 10 is 16. Now, does everybody remember what this last number always represents when you divided polynomials? What do we call that guy again? It was the remainder. Now, does that remainder look familiar? Yeah, what is it? Literally, when you're using synthetic division, you're using it to evaluate polynomials. The remainder, when using synthetic division, is literally the output when you're evaluating that polynomial at that specific value. So, I'm not sure about you guys, but which one seems easier? The second one. Now, if you could do, that's what we're doing today. We're literally taking a past, and we're pretty much doing the exact same thing to solve the exact same problems that we've been practicing. So if you know synthetic division, you know the little stuff that you have to watch out for, you're going to be golden. Question? Any chance? No? Okay. All right, so this one was kind of a baby one to get started. You want to start a monstrosity problem that you're like, okay, this is 10 times easier? Sure, right? Do we really have a choice in a way? All right, so try the next problem. Now, I wouldn't do this to you guys. I'm not going to have you do direct substitution. I don't want to see you guys do this really long to the 4th, to the 3rd. Just use synthetic division and see if you got it. And I'll tell you what the answer is, just in case that way you're not waiting and you know you did it correctly. Your answer is supposed to be a positive 8. All right, so can someone remind me what the multiplier is in this situation? Yeah, it's just literally what you are evaluating your function at, or what value you're evaluating. The next thing you need to do is just figure out what the leading coefficient is of each and every single term that you have. So notice that there is a lot of terms, but that's okay because we're just really adding and subtracting, or multiplying and adding. So my first term is going to be, the first coefficient of my term is a 3, next one's a 2, negative 5, I got a 1 and a negative 2. Does everybody agree with that one? I think so, right? Now let's go ahead and do the math. Let's drop down our 3. Remember, anything underneath the line you multiply. So negative 2 times 3 is a negative 6. You add, which in this situation would be 2 plus negative 6, which is a negative 4. Multiply gives you that positive 8. Add them, which is a positive 3. Multiply, negative 6. Add them, negative 5. Multiply equals a positive 10. And you finally get to that remainder, which is your solution, which is a positive 8. If you have trust issues or something like that, of course, plug it in, solve it using direct substitution. You'll notice that you do get an 8 out. And that's pretty much it. Now, there's one thing I'm going to have you guys just be aware of. I'm not going to have you actually do it, so that way you can get started on your guys' homework if you choose to, which is the following problem. Oh, I forgot to remind you guys that what you would write to is what's called the remainder theorem. It states that if a polynomial f of x is divided by x of minus a, the remainder is the constant f of a. And I'll go into a little more detail what that exactly means tomorrow in terms of why does synthetic division work. If I plug in a value, why do I get the same thing when I do the synthetic division? And I'll show you that a little bit tomorrow. But before we go there, I want to make sure you got the setup correctly for problems like number 2, just in case you arrived to your guys' homework. Now let's start the setup together. If I were to do the setup, what would be my magical number when trying to solve C of 4? What would be my multiplier? 4. Now remember that whenever you're finding those coefficients, you need to have the coefficient of every single degree. Now look at this term. What is the degree of this term? 3. What's the degree of this one? 1. And the degree of this guy? So remember those place values. When you have a missing degree, you need a place value when listing your coefficients. So for instance, I will write down my 3. Do I have a second degree? No, so I would put down as a 4. Then I'd go to my negative 1, or my first degree, which is a negative 4. Then of course your constant, which is a 2. And then you just go ahead and do the math after that. I'm not going to have you do it because you're going to have to do this in your homework. It's just like, hey, watch out. Make sure that you don't forget that when you're missing a degree in that polynomial, you put that 0 for that place value, okay?